Welcome to The Explainer. Today we're looking at something pretty incredible: how AI is learning to read the news to predict natural disasters before they even happen. So think about this for a second. What if we could predict something as chaotic as a deadly flash flood just by reading the news? It sounds a little like science fiction, doesn't it? Well, we're diving into a fascinating Google AI that's actually doing it, turning the world's news into forecasts that can save lives. All right, here's our roadmap. First, we'll talk about a massive problem, a huge gap in our global disaster data. Then, we'll introduce the AI Google built to fix it, see how it magically turns headlines into hard data, and then measure its real-world impact. And of course, we'll look at what all this means for the future. Okay, let's get right into it. To really appreciate the solution, you've got to understand the scale of the challenge they were up against. You see, for something like an earthquake, we have sensor networks all over the planet. But for flash floods, not so much. There isn't a single unified system to watch them. This creates what experts call a data desert. Basically, a giant black hole where all the historical data we need to build good prediction models should be. So why is this gap so tough to close? Well, our current systems, as good as they are, have some major blind spots. Satellites, they can get blocked by clouds, and they often miss those really quick, localized events. Even the heavy hitters, like the GDAX database, are mostly focused on the big, high-impact disasters. That means countless smaller flash floods just never get recorded. They're basically invisible. And this is the exact problem Google decided to tackle. Their solution is so clever because it doesn't need new hardware or new sensors. Nope, it uses a resource we already have in abundance. So meet Groundsource. It's an AI with a really cool job. It treats all the news articles and reports from around the world as one giant, messy, unstructured memory of everything that's ever happened. The AI's task? To read that entire memory and organize it into clean, structured data that computers can actually understand and learn from. Okay, so that sounds great in theory. But how does it actually work? How do you take a local news report written in any language and turn it into a precise data point you can use in a forecasting model? It's a pretty slick four-step process. First, the system just inhales millions and millions of news reports in about 80 different languages. Then the AI gets to work, reading the text to pull out the key details. Where did it happen? When? And how bad was it? Next, Google Maps steps in to turn vague descriptions like near the old bridge into exact GPS coordinates. And finally, all this verified info is packaged into a single usable data point. Now, the engine driving this whole thing is Gemini, Google's advanced AI. And its real superpower here is understanding context. It's smart enough to know the difference between a news report about a flood that's actually happening versus an article that's just talking about the future risk of floods. That's a crucial distinction. And you know what? It's really accurate. When humans checked its work, they found that 82% of the events it pulled out were practically useful. That means it got the location right, down to the correct district, and timed the event within a day of its peak. That's more than good enough to be incredibly valuable. Okay, so this is where it all pays off. Let's talk about the incredible scale of this new dataset and the impact it's having in the real world right now. So the system has built an archive of, get this, 2.6 million historical flood events. To put that into perspective, that's an absolutely massive leap forward. Previous datasets might have had maybe tens of thousands of records. This is a whole different league. And the data isn't just deep, it's wide. We're talking about a truly global picture here, covering more than 150 countries, with records stretching all the way back to the year 2000. So how does it stack up against the old ways? Well, it captures pretty much all of the same major severe events as the benchmark systems. But, and this is the crucial part, it also identifies thousands upon thousands of those smaller, local flash floods that other systems were completely missing. It's finding the data that was invisible before. And this isn't just an academic exercise. This historical data is the fuel for a brand new, much more accurate forecasting model, one that can predict urban flash floods pretty much anywhere on Earth. Those new forecasts, they're already live in Google's Flood Hub, and they're giving communities life-saving warnings up to 24 hours in advance. It's literally turning yesterday's news into tomorrow's protection. This is obviously a huge deal for floods, but you can probably see where this is going. The potential here is so much bigger. You bet. The same basic idea is incredibly flexible. Google's already looking at applying this Groundsource framework to other disasters where we're starved for good data. Things like droughts, landslides, heat waves, even avalanches. And this really gets to the heart of a broader mission. The point isn't just to use AI to stop bad things from happening. It's about proactively using these incredible tools to build a safer, more resilient future for everybody. Which leaves us with a pretty powerful final thought. If an AI can turn all of our unstructured news into a solution for a huge global challenge like flooding, what else is hiding in plain sight? What other massive problems could we start to solve if we just taught our AI to read between the lines?